Okay, so the beginning of this video is going to be a pretty much a in-depth discussion about absolute value and to clear up some things or to talk about it. If you don't want to hear all of this discussion, I'll post down in the description where you can jump to in the video just to see a pure example of it being done. But anyhow, let's talk about absolute value. So one of the things about absolute value that a lot of people commonly remember it as is that it is a distance from zero. And it's something that's commonly taught when it's first introduced. Your teacher would draw this number line in here and they would put a zero in there. And all of a sudden they put the number to the right of that and they put the number to the left of that and they say, okay, that is a distance from zero. I don't particularly like going off of that definition or remembering it as such. And the reason for that is because once you start getting into linear equations, just saying it's a distance from zero can be kind of misleading. And what I mean by that is zero, once you start getting into linear equations or quadratics, or whatever equation you have it, is a relative term. Meaning it's not always the number zero that you're talking about. And when you introduce it as being a distance from zero, a lot of people get stuck on that it has to be from this number of zero. When we're talking about a distance from zero, we're really talking about the value that makes something zero. So a better way that I like to remember it is this idea is that it is a distance that a point is from a function's zero. It's a little tiny bit different. I just throw in there a function's zero. And what I mean by that is that down here I have written this f of x is equivalent to zero. And then from there we have a distance to the left and a distance to the right. So it's not necessarily always going to be a distance from the value of zero. It's going to be a distance from a point, okay, that is going to make everything become a zero. So that's an important concept, and I'll show you what I mean by that in a second. But let's pretend that we have some equation, and we have it as just y equals, because we're going to be talking about linear in this case, y equals 1/2 x plus 1, okay? And we're going to go ahead and graph this, and when we go ahead and graph it, just as a regular function, we're going to talk about something, and then I'm going to put absolute value bars around it and talk about how has it changed. So if we graph the line like normal, so we go up to +1, go up 1 over 2, up 1 over 2, or down 1 to the left 2, and we draw this line in. So this is what the graph of y equals 1/2 x plus 1 looks like. But if I were to throw absolute value bars, okay, around this equation, we now have a problem. And the problem we have is that anything from the point of zero and below all of a sudden becomes red. It's no go. You can't use it. However, everything above, okay, we can still use. So that's green. So on this line, these things above are still good, but the things below, again, are now red. We can't use them. However, absolute value has a property, and the property that absolute value does is it just takes all of those negative values that we might have down here, okay, and what it does is it ends up taking them and making them into a positive. So the way it does that is it simply takes this function, all right, so it takes this function along this line. So down here, this is still the equation 1/2 x plus 1, and what it does is it multiplies all of these outputs that are below 0 by -1. And when it does it, all of the multiplication of -1 does is it changes the sign. So all of a sudden, the point that was once down below now pops up top, okay? And what we have now is that this line forms, and what we get, okay, is this new, let me connect that a little bit nicer. What we have now is that we have this, we have this new line, all right, that forms, that looks like this. And when we have those, it now changes those reds into being greens, like such, okay? So now we have this new line. So what this forms for the absolute value is this V-looking shape. However, what we have here is that on the left-hand side, the reason these points exist after the point of 0 over here is because we multiplied our original function, okay, by -1. So we took that and multiplied it out, so plus 1. And over here, these values on this side are just the regular function of 1/2 x plus 1. So that's an important concept going forward. We are going to talk about this 0 value because to the left of that point, we multiply everything by -1. To the right of that point, we leave the function as is. Okay, we don't mess with it. We don't need to, because what we notice to the right of that point, everything is okay. All right, so the point is we need to find this critical point of 0 to understand that anything to the right of it is going to be okay, but anything to the left of it, okay, we need to multiply by -1. And that's why it's important to find that function of 0. So that is kind of like the beginning of it. So what we're going to do is we're going to go to an example. First, I'm going to show it graphically, and then we'll talk about just the pure mathematics behind it. So let's say we have this equation. It says 4x plus 2. So the function we want to graph is y equals 4x plus 2. So we go ahead and do so. So we graph it. So there's an x plus 2, so up 4 over 1. Okay, so this up 4 over 1, 1, 2, 3, 4 over 1. Okay, up 4, 1, 2, 3, 4 over 1. All right, then we draw that line in. Yes. So here we go. Sorry, it's not going to be fantastic. Let me do that again. That's an awful line I just drew there. Okay, so there is that line. So now, again, following the same rule, this is the absolute value. So anything that's below here, as soon as I get to that point right there, anything below it is red. It's no good. So what we do is we multiply this by -1. So take that function, okay, multiply it by -1, and what you're going to have is that those negative values, okay, are now going to bounce back upwards like such, and then they'll be okay. So what we have now is this, okay, this green V that is starting to form. Now, well, not great, okay. It's okay. So now we have these values, yes? So what we now have here, right, just to remember, is that we need to know when is this new function, all right, going to have the same coordinates, okay, because we're making them equal and we're talking about linear. I want to know when does it pass through this graph here of y equals 1/2 x plus 4. So if I graph that very quickly, go up 1, 2, 3, 4, plot that point, up 1 over 2, draw that in very quickly. What we notice is that it happens twice. It happens here and it happens here, somewhere over there. Now, this is just graphically showing it to you, but if you notice, if this is my point of 0, one point happens to the left and the other point happens to the right. So that is a case that usually will happen if we have a intersecting twice. It doesn't mean it always has to intersect twice, but in this case, if it does intersect twice, generally speaking, will happen once to the left of that 0 and once to the right of that 0. Just an important concept to understand. All right. So that means I'm going to be looking to calculate 2 answers on the next page, and let's talk about the mathematics of actually getting those points. Let's talk about how we calculate that f of x equaling 0, and let's talk about how we get those 2 points. All right. So here we go. The example of the mathematics behind it. So after the explanation, took a little while, sorry, but it's important stuff. So here we go. The mathematics behind this is, first things first, we need to find out when my function is equivalent to 0. And the function I'm talking about specifically is the one that's in the absolute value, because that's the one that's going to form the v. So what we do is we take that function of 4x plus 2, and we set it equal to 0. So now when you solve this, you're going to subtract 2 from both sides. You'll get 4x is now equivalent to -2. Divide by 4, okay? -2 divided by 4 is -1/2. So before, if you were watching this whole video, you noticed that when I drew my line that went down to the x-axis, that happened right around -1/2, okay? So why is this value important? What's the importance of this value? Well, anything to the left, okay? Anything to the left now of -1/2, we have to multiply by -1. So I got to multiply my function by -1, okay, for that value to exist. Anything to the right, we just leave as normal. So what we say here is that I have one equation where, okay, we had this 4x plus 2, all right, and if we left it alone, we would getting to the point to the right. It also intersected that line of 1/2 x plus 4. So there's one equation. However, we did have this other equation. So now for this one here, sorry, let me backtrack a minute. Okay, this is when the point was to the right of that 1/2. So what we generally say here is we'll say this particular case was when the x was to the right of negative 1/2. Well, how do you show a number to the right? You just say it's greater than it or equal to negative 1/2, okay? So the next thing we do is what we noticed is that, okay, when I was to the left of it, okay, we had to multiply that function. To produce those actual answers, we multiplied that original function by -1. So we do -1 times 4x plus 2 is now equivalent to 1/2 x plus 4. And when you multiplied it by -1, that was when my x was less than or equal to -1/2. All right? So now what we need to keep in mind is, now when we solve this, we want to make sure, okay, that if we did our mathematics correct, okay, that we're going to find a value that indeed would be an x greater than -1/2 or equal to it. And the other one we will do is less than or equal to that -1/2. So we solved the first one. So going through and solving it, subtract 2 from both sides. I get 4x equals 1/2 x plus 2, right? Take away 2 from 4, you get 2. Then I'm going to take away a half from both sides. So subtract 1/2 from 4. So minus, I'll show that step here, minus 1/2 x. That takes care of that side. So 4 minus 1/2, I'm going to write it as a fraction. So that's 7/2 x equals 2. To solve for x, multiply by the reciprocal, and I get x equals 4/7. So the next thing we just check is this value indeed greater than -1/2? The answer is yes. Check. That's a good point. We have calculated. So at 4/7, that is the value that I can plug in for x that will make both of these things the same on both sides. So that's one value. We did have another value. So for this one, the graph was nice because it showed me that I had 2 answers and that I should have 2 answers. So now we go through and we just use the distributive property or distribute your -1 through. So you get -4x minus 2 equals positive 1/2 x plus 4. So what I'm going to do is I'm going to add 2 to both sides. I get -4x equals 1/2 x. So adding 2 to 4, I get plus 6. All right, next thing I'm going to do is subtract 1/2. So when I subtract 1/2, that gives me -9/2 x equals 6, multiplied by the reciprocal, and I get x is going to be equivalent to, okay, so I'll just show this one for this one so you understand it. So I'm multiplying it by 2/9, multiplying it by -2/9. So my answer to this one is actually going to be -4/3. Okay, so 6 times -2/9 is -4/3. And what you have there is we need to check this answer very quickly against the -4/3. Is that indeed less than -1/2? The answer is yes. And what we have now is the answer to our 2 points at which the x-coordinate when the line passes through the other line. So you can think of these, you may have heard of systems of equations before, you may not. But a system of equations is where 2 lines intersect on a graph. That's essentially what we're dealing here with. So I hope that helps. But let's do another one just to solidify this idea to say, do I always have to have 2? And the answer could be yes. The answer could be no. There could be no. There could be none or no intersection points, okay? So let's do one more here. All right, on to the last one here. It says 3x plus 2 equals -1/4 x minus 4. So again, if I'm going through the steps, the first thing I'm going to do is find that function 0, okay? And the reason I'm finding the function 0 is so that I can find the points that make it flip to the left or make it flip to the right. Okay, so here we go. So the function 0, I will say, is when that f of x is equaling to 0, and the specific function I'm looking for is the one inside the absolute value bars, okay? So what I do is I go 3x plus 2 is equivalent to 0. So minus 2 from both sides, I get 3x, then equals -2. So I get x equals -2/3. So the function 0 is -2/3. Why is that important again? Okay, so if I draw a number line here, okay, just to show this, at -2/3, all right, to the left of -2/3, any outcome to keep it positive, I had to multiply my function, okay, by -1. To the right, it was just that function, and it will always be that way for absolute value. All right? So, Continuing on with this, just finish off this example. I now can say that 3x plus 2 is equivalent to negative 1/4 x minus 4. So if I keep it positive, right, it's when my x values, all right, were greater than or equal to negative 2/3. So important concept there, right? So then the next thing is, okay, well, the other side, so the opposite side, well, I had to multiply again to get those values to be positive. Had to multiply it by negative 1, 3x plus 2 equals negative 1/4 x minus 4. And to keep in mind something here very important, I only had to multiply this function, okay, by negative 1 when it was to the left of that point. So what I'm going to do is just record that and say, okay, I only had to do this presuming that my x was less than or equal to, okay, 2/3. All right, so important idea there to make sure you're keeping that in track. And the reason we're saying equal to is because just in case, because it is an equivalency, just in case I come up with something that does equal it. All right, and just to let you know that that is okay. So now we go ahead and solve it, and once we're done solving, the equation's over, and then we're done. All right, so here we go. So we go ahead and solve, so minus 2 from both sides, so I'm going to go ahead and minus 2 from negative 4. I get 3x is now equivalent to negative 1/4 x minus 6. Take away 2 from negative 4, you get negative 6. Next step I'm going to do is I'm going to actually add 1/4 to both sides. And when I add 1/4 to both sides, that's going to give me 13 over 4x equals negative 6. And the last thing I'm going to do here is I'm actually going to multiply by the reciprocal and multiply both sides by, let's just show that here, is 4 over 13. Multiply this by 4 over 13, and what that gives me is x is now equivalent to negative 24 over 13. So that is approximately right around negative 2. We'll just say that for now. It's approximately there. It's pretty close to negative 2. So the reason I'm just doing the approximation for this case is that this number is clearly greater than, or is clearly, okay, a number that is smaller than negative 1, all right? Now, up here, when I evaluate this, and this is important, okay, this value, for this to be an actual true calculated value, something that actually does in this particular case work, it would have had to have been a number that was greater than negative 2/3. Now, you have to be careful about negatives. Negatives can be tricky. To be greater than a negative 2/3, right, you actually have to get in closer to 0. So you're picking numbers like negative 1/2, negative 1/4. You're not picking numbers like negative 1, negative 2, and negative 3, and such forth like that, okay? Just to keep that in mind. So we have a problem here. This problem is what we call an extraneous root. It doesn't actually exist because, all right, in this particular case, again, for this video, all right, we're talking about that it has to make it so that it would intersect to the right, and this value here doesn't actually work. It's what we call an extraneous root. Even though the math was done correct, it doesn't give us a proper answer. So then we go through. On to the next one. So we distribute the negative through, so we get negative 3x minus 2 is now equivalent to negative 1/4 x minus 4. I add 2 to both sides, I get negative 3x is now equivalent to negative 1/4 x minus 2. I'm going to add 1/4 to both sides. And when I add 1/4 to both sides, I actually get this negative 11 over 4x is now equivalent to negative 2. And now when I do this, I'm going to go ahead and multiply both sides by negative 4 over 11. Multiply this by negative 4 over 11. And what I have now is that x is actually equivalent to 8 over 11. So what we needed to check is that this point as well, okay, had to be less than negative 2/3. Well, any positive is never less than a negative, so we have another problem here. And what we have is that this one doesn't work either. So just because we have an equation that says it works, the interesting thing here is that what we have going on is that we've got this no solution. These two things do not intersect. So the answer to this is no solution. So for this video, okay, I've shown one where it intersects twice and I've shown one where it doesn't intersect. There are times where they will only intersect once. I'm not going to do that for this video because it's already getting pretty long, but it could happen once. So for absolute value, you could have it intersect once, twice, or none. So that's an important concept to understand. If you're talking about two linear functions, obviously if you start throwing in quadratics, it's more possibilities. But for an absolute value linear function, you could have one, two, or no answers, okay? And I could show this with a graph, but if you draw the graphs here, what you'll see is after you do that little v thing, that the negative 1/4 x minus 4 actually passes below the whole graph, and it will never intersect. So I hope that helps with any of your understanding on absolute values.